All right, so day 3 of prime factorization. We've talked a lot about what makes a prime number, so I just got the prime numbers listed out here. Remember, when we do this prime factorization, we continue working until we hit one of these prime numbers and then we move on. So 24. I need to think what goes into 24. A lot of places you can start here. I'm grabbing my calculator in case I get stuck, but I know it's an even number, so I know I can start with 2. 2 times 12. 2 is a prime number. This branch is finished. Is 12 a prime number? No, it's not. You've got that list of prime numbers. You could have that open in a separate tab so you can kind of reference back to it. So 12 breaks down further. 12, what goes into 12? Again, I grab the calculator if I need to. I know it's an even number, so it's 2 times 6. 2, prime number. 6, not a prime number. Be careful with 6. A lot of people goof it up. Remember, we're multiplying here, so 6 would be 2 times 3. That's multiplying. Don't do 3 and 3, that would be adding. Remember, all of this prime factorization stuff's multiplying. So I've got 3 2s and a 3. So in standardized notation, 2 times 2 times 2 times 3. In exponential notation, 2 to the 3rd power times 3. Standard form, exponential form. All right, moving on. 40. Again, it's an even number. I could start with 2. I see the 0 at the end, so I know 10 goes into it. So I'm going to start with 10. Okay, so 10 would be 4 times 10. Does 4 break down? Is 4 a prime number? No, it breaks down. It's not a prime number. So if something's not a prime number, break it down into its primes. 4 is 2 times 2. Prime numbers, done, done. 10, 2 times 5. Prime number, 5, prime number. So now my standard form would be 2 times 2 times 2 times 5. My exponential form, 1, 2, 3. There's 3 2s there and 5. Moving on, 36. Again, what kind of number is 36? And you're going to find a lot of these, almost all of them, are going to be even numbers. You can start with 2. Let's not start with 2. Let's start with something a little bit bigger. Can I think of anything else that goes into 36? So, some of you, I heard, said 4 times 9. Some of you said 6 times 6. Let's go with that 6 times 6. So 6 times 6, is 6 a prime number? Nope, not a prime number. Break it down. 2 times 3. Remember, multiplying here. 2 and 3, are those prime numbers? Sure are. Break down to 6. Again, a 2 and a 3. When you write these answers, especially when you're doing it on the computer, make sure you put your stuff in order, okay? Because it's only going to read it a certain way. So standard form answer here is 2, 2, 3, 3. Exponential form, I've got 2 2s. I've got 2 3s. Okay. Quick note about using that computer, make sure you're following those directions. I try to make it pretty explicit, so make sure you're entering the things the way they need to be entered, and it'll grade it correctly for you. All right? Down here, let's do it again. Number 4, so 20. Again, try and come up bigger numbers if you can. Notice if I'm picking 2 every time, this gets kind of long and it's easy to lose track of things. If I can pick bigger numbers, the trees get a little shorter. So if you can start with some bigger numbers, it'll save you layers to or branches on that tree. So when I see 40, I'm thinking, or I see 20, excuse me, I'm thinking 4 times 5. Is 4 a prime number? Nope. 2 times 2, those are definitely prime numbers. We've seen them a lot. 5, we've seen that. So 2 times 2 times 5. My exponential, 2 squared times 5. All right, number 5. Again, I got a big number, 120. I need to start with some big numbers so I'm not doing this problem forever. It ends in a 0, so what goes in? Exactly, divisible by 10. So I'm going to start 12 and 10. So now I'm going to break down that 12, because it's not a prime number. 12 is 2 times 6. Prime, 6, we've done lots of times before, is 2 times 3, and those are both prime. 10, not prime. 10 is 2 times 5, and those two are prime. So now I've got my list, everything's broken down. I've got 1, 2, 3 2s, a 3, and a 5. Again, when you're writing this, we're taking all these prime numbers into account. Okay, so in exponential form, those are 3 2s, a 3, and a 5. Number 6, 145. So, is that a prime number? I didn't write my list out that big, but hopefully when you look at that, you see the 5 at the end, and you know 5 goes into 145. So I'm going to grab my calculator here, and I'm going to go 145 divided by 5, 29. All right, so this breaks down to 5 and 29. Is 5 prime? Sure is. Done that lots of times before. Is 29 prime? I don't know, check. Oh, there it is, right there on the list. Good. So 29 is prime. That's it. 5 times 29. So in standard form, it would be 5 times 29. In exponential form, it's 5 times 29. There's one of each of them. Very good. All right, last one here. So what number do you want to start the multiplication with? I know what I want to start the multiplication with. We've done it a number of times before. When we see that 0 at the end, that's an indicator, a quick way to figure out where to start. Multiply or divide by 10, find the factor. 15 times 10 is 150. Is 15 prime? Nope. So what goes into 15? Very good. 3 and 5. Both are prime. 10 is 2 and 5. We've done that plenty of times before. So I've got a 2, a 3, and 2 5s. In exponential form, 2 times 3 times 5 squared. So we're going to be doing a lot with prime factorization coming up, so make sure you've got this now. This is our third day. If you're still having questions, reach out and we'll get you straightened out. Good luck.